Hello class. So this is the final video here on angle and arc relationships. There's just more here, and there's really a whole lot in geometry about this, but this is what we're going to study in this class. So what I've done is I've gone ahead and written down the notes just because it does take a couple seconds to do that, and I'm going to quickly talk through it, but if you need more time, just go ahead and hit pause so that you can draw what you see on the screen. So the first thing that I've drawn up here is a situation where you have two chords inside of the circle and they meet at a point interior to the circle, forming this angle right here. Actually, it forms four angles, and you know that two are like they're vertical pairs. And if I say pick a pair like these two vertical angles right here that would be congruent to each other, I can mark them off. These vertical angles are going to be congruent, and they're going to meet these arcs out here, but unlike if they were central angles, these arcs are not necessarily congruent to each other. What we can say, though, is that the measure of this angle, either one of these vertical angles that I have marked off here, this angle 1, the measure of that angle would equal half of the sum of the arcs. So this arc over here, arc X, plus arc that has a measure of y, right? So half the sum of those two. Down below, you see another type of relationship where instead of the segments meeting on the inside of the circle, you have them meeting outside of the circle, forming one angle out there that I call angle 1 in every situation. And the relationship is the same in each one, whether like in the first problem you have two. This is a case where you have two secant lines. There's two secants here. This is one secant and one tangent. And then this one over here is having two tangent lines, two tangents. And in every case, the measure of that angle, which will be on the other side from the x, will equal half of the difference between arc X and arc Y, and arc X is always the bigger arc, so it's the arc that's furthest from that angle 1 that is back there, formed in every case. Okay, so I've quickly gone through that again. Go ahead and hit pause if you need a second to write that, or back up if you need to hear what I've said again. I'm going to clear this out and go ahead and begin with the examples. Example 1 involves a circle, of course, with two chords inside of it like this. And again, the point where they intersect is not necessarily the center, and it's certainly not the center in this case. Not just because of how it looks, but because we're going to know that's 70, and then this one is going to be 116. So the relationship that we know from before, what I just spoke about, is that this angle will equal half. By the way, we are going to be finding the variable x in each one of these situations. It will equal half of the sum of the arcs. So half of the arcs that meet them, which are 70 and 116. So 70 plus 116. And then so you just put this all in your calculator. You'll find that x equals 93. And that's all there is to it. Let's go to a second example. Second example with the circle. This time we're going to have two secants, and these secants are meeting outside of the circle. So this is x that we're going to be looking for. Make it a little bigger. That's x. This is 20 degrees. These are measures now, not actual lengths, just like in the problem above here. These are measures. I should put a little degree symbol so you'll know that they're measures and not arc lengths. It's just how much it's bent. So it's bent at a 90-degree amount. This is bent at 20. And anytime I have this intersection now on the outside, I can find out that that angle back here, x, will be 1/2. Not the sum this time, but the difference. And how do I subtract? I always take the outer arc, which is 90, minus the inner arc, which is 20. All right. So this is a vague slight connection to the previous lesson where we did this. 1/2 of the intercepted arc will give you the inscribed angle, but it's kind of twist on that, where you add if the intersection's on the inside and you subtract if the intersection's on the outside there. Of course, we're not talking about inscribed angles either here, so that's the difference there, but there's sort of a connection between these two types of problems. So I just did the work there as I spoke through that, but half of 70 is 35, and so that is the measure of that angle that's outside there. Okay, I'm going to go ahead and clear out once again. Let's do one more or two more examples. Example 3. Let's suppose we have a circle. This time, in this situation, I want to have a circle that has 2 tangents. All right. Okay, 2 tangent lines, and this is x that we're looking for. Means that a point there, a point there. All right. We had a relationship with these 2 tangents outside where we talked about this segment being congruent to this segment here, being congruent to this segment there, but that's not needed because I'm no longer asking about segments or measurements of segments inside this circle. I'm looking for angle measurement. And the only other information I have out here is that this arc is 240 degrees. So I can go ahead now and figure out what x is going to be. So x will equal 1/2 of the difference, the intersections on the outside. So the outer arc, which is 240, minus the inner arc. Now, I don't have the inner arc just yet, but that won't be too hard to find. I can simply know that if this is 240, then the other part of my circle to add to equal a whole 360, this would have to be 120. I'm missing this piece in here, so this has to be 120 because the 2 have to add to equal 360. So once I put that in place, then the rest of this is straightforward. So x is 1/2 of 120, which is 60 degrees. Okay, very good. And then number 4, last one. As you may have guessed, we're going to hit that last case. This time, instead of having 2 secants or 2 tangents, let's have one of each. And the information is, well, first off, this is going to be x right there, right, we're looking for. This arc measure is 65 degrees. This arc measure out here is 120 degrees. So increasingly, I'm kind of mixing it up a little bit. Let's go ahead and start. You'll see here in a second what I mean by that. X is 1/2, and then I got to do the outer arc minus the inner arc. Well, here's the angle. So the outer arc would be this piece over here. Let me highlight it. This would be the outer arc, going from here, and it would stop right there. But I don't have it yet. Well, I do know that this is 65 and this is 120. So if I did 360 minus that 65 minus that 120 to find out this piece here, I would find out that it actually measures 175. All right, and that's what I need to go in the first part here, 175, because I got to do the outer piece minus, then I already know 65. Close it off. So x will equal 1/2 of 175 minus 65. 1/2 of, what does that give me? 110. And finally, x would equal 55 degrees. All right, well, I hope that you have enjoyed that and are continuously enjoying this unit. I'll see you in class or in another lesson.